All right, we're going to go through and do our station review, and then we'll look at the similar figures review to get ready for our similar figures test. Station number 1, we're given this diagram, and I filled in the side lengths that are given up here. All right, and we want to make a flowchart to prove the triangles are similar. When I look at this picture, I notice on the bottom triangle here, it goes side, angle, side that we're given. But on the triangle up here, we just have a side and an angle. We don't know the side RT, so that's why I labeled it X. So we can't do side, angle, side. We can't do side, side, side because not all the sides are labeled. So that means we're left with making an angle flow chart. And that's what I'm going to do. And in one of my bubbles, I'm going to say what is given in this problem. And what we're given is angle Q and angle T are both 90 degrees. And so they are congruent. Okay. And so now I need to look for a second pair of congruent angles. And I notice we have vertical angles here by the letter R. So when we do vertical angles, we need to remember we use 3 letters to name them. And so I'm going to name one of the angles as SRT. And that is congruent to, let's do it in the same order, PRQ. So now I have my 2 angle bubbles filled in, so I can go ahead and finish my flow chart and say that triangle, we'll do SRT, is similar to triangle PRQ because of angle similarity. Now that we know the triangles are in fact similar, we can go ahead and solve for RT, which is X, and I can make a proportion in order to do this. So just to point out, QP corresponds with ST, and so I'm going to do, let's see, 16 over 5 equals, and then on the other one, I went big triangle to little triangle, so I'm going to go big triangle 12 over X on the other side. And I'm going to cross multiply to rewrite my proportion. I get 16x on one side, and then 5 times 12 is 60 on the other. Now I'm going to just solve for x. I'm going to divide both sides by 16, and x will equal 3.75. Now I can double check my answer by plugging x back in, and 16 divided by 5 in my calculator gives me a scale factor of 3.2, and 12 divided by 3.75 also gives me a scale factor of 3.2. So I got the same scale factor twice. I know my answer is correct. Moving on to station number 2. Here we have these overlapping triangles. So first, before I try to solve for x, I just want to redraw my 2 triangles. My small triangle in red has side lengths 20 and 18. And then my larger triangle in green here, this side is x plus 20. And on this side, it is 18 plus 9, 27. All right, so it's important to add those parts together when you make the big triangle. Now I'm going to set up my proportion using corresponding parts. 20 corresponds with x plus 20 in the big triangle. So I'm going to go 20 little triangle over x plus 20 big triangle. Set that equal to 18 in the little triangle over 27 in the big triangle. And just like the last problem, I'm going to cross multiply 20 times 27, which is 540. And then on the other side, I'm going to cross multiply 18 times x plus 20, but I'm going to write it out like this. This is 18, and then parentheses x plus 20, because I have to multiply 18 by both terms. So that's going to look like 18x plus 18 times 20 is 360. I want to get x by myself, or by itself, so I'm going to subtract 360 from both sides. And so I get 180 equals 18x. And then I'm going to divide to get just x by itself. X is going to be 10 in this problem. Moving on to part B. And part B, we're going to do the same thing. We have the overlapping triangles. So my small triangle in blue has side lengths of 24, 30, and 12. And in my big purple triangle, it's 30 plus 10, that's 40 on the bottom. You got 24 plus x on this side, and then y. Okay. And I'm going to go ahead and pause here and set up the proportions real quick. Double check your own answers. All right, so 24 in the little triangle over 24 plus x in the big triangle equals 30 in the little triangle over 40 in the large triangle. I'm going to go ahead and cross multiply. 24 times 40 is 960. And on the other side, 30 times 24 plus x, that's in parentheses. That's going to turn into 30 times 24 is 720, and 30 times x is 30x. Again, we want to get the 30x by itself, so I'm going to subtract 720 from both sides, and I'm going to get, let's see, what is this, 240 equals 30x, and then divide both sides by 30 to get just x equals, and this would be x equals 8. All right, so that's one of our answers. And then on the other side, we want to do that again. We can cross multiply 12 times 40. That is going to be 480. And on the other side, we get 30y. 30 times y. Okay. Divide by 30 to just get 1y. And y is going to equal 16. All right. Let's go ahead and move on to the next station. Station number 3, Bao has rushed through the quiz, and he's made a mistake solving for missing side lengths. And so the question is, did he mess up x or y? And the answer is he messed up solving his proportion for y. So Bao wrote 8 over y equals 5.5 over 11. So what the problem is, for his first ratio, 8 over y, he went the big trapezoid over the little trapezoid, right? 8 is big trapezoid, y is on the little trapezoid. He's got to follow that same order with the other ratio, but he wrote 5.5 from the little trapezoid over 11 from the big trapezoid. So he has to flip 5.5 and 11. So it should look like this, 11 over 5.5. And so now we can solve this. And again, we can cross multiply. And 8 times 5.5 equals 44 on one side. And then on the other side, you have 11y. And so y in this problem will equal 4. And he did set up this part correctly, so x still is 16. Moving on to our next station, station number 4. And here I've already set up the flow chart. Just wanted to point out I color coded the corresponding sides. So littlest side I did in blue on this triangle, and littlest side on this triangle I also did in blue. I'm going to use those two numbers for one of my ratios. I did the same thing for the middle side. 15 and 18 in both of these triangles are in the middle. And then the largest side or longest side is in green, 20 and 24. So I can color code my corresponding sides. That helps me make my ratios. And I find they all have the same scale factor, which means they have proportional sides, which means we can prove the triangles are similar using side-side-side similarity. All right, if you need to look at the flow chart, go ahead and pause the video. Otherwise, I'm going to move on to station number 5. So for station number 5, we want to create 2 flow charts that are different. And when we look at this problem, we want to just first take a guess. What is the shortcut that we're going to do? Our 3 shortcuts are angle, angle, side, and side, side, side. Now I can cross off side, side, side because I do not have all of the sides on both triangles. I'm missing one side each in both triangles. I can't do side, side, side. Okay, so the 2 flowcharts I'm going to make are angle, angle, and side, angle, side. Let's start with the angle, angle flowchart. In order to do that, we have to have 2 pairs of congruent angles. We have 1 pair of congruent angles, angle M and angle G. All right, so I'm going to go ahead and make that bubble. And angle M is congruent to angle G, and that is given because they are both 50 degrees. Where am I going to get my second congruent angle? Well, I can go ahead and I can either find O or N, and I'm going to do N because my name is Nate, and I know that the angles in a triangle have to add up to 180 degrees. This is the triangle angle sum theorem. And so the measure of angle N is going to be, let's take a look. It's going to be 45 degrees when I solve for it. So 45 degrees right there. So now I do have 2 pairs of angles. Angle D and angle N is also going to be congruent. But before I put that into the flowchart, I have to state what I did first to get angle N. So the measure of angle N was 45 degrees, and we found that by doing the triangle angle sum theorem. I did that first, and then I can say angle N is congruent to angle D because they are both 45 degrees. So that's my second angle bubble. And now that I have both angle bubbles, I can then say the triangles are similar. So triangle, let's say DOG is similar to NAM. Again, I'm double checking that I have the corresponding parts. D corresponds with N, O and A correspond, and M and G correspond. So that's one of my flowcharts. Now I'm going to make my second flowchart, and with the second flowchart, side angle side, I want to look for my corresponding sides. So 6 corresponds with 9, and 4 corresponds with 6. And side angle side, I need the angle in between. And so the angle in between is angle D and angle N. All right, and because I'm going to use angle N again in my flowchart, I am going to copy down what I did for angle N in the angle flowchart. So it's going to look like this. I'm going to do the same thing. Measure of angle N was 45 degrees. And again, that was my triangle angle sum theorem. Okay. And I'm again using that to say that angle N is congruent to angle D because they are both 45 degrees. So I have my angle bubble done, and now I need my two side bubbles. And so we already said that 9 and 6 correspond, so 9 divided by 6. Let's see, that is going to be 1.5, and I divided to find the scale factor. And then my other corresponding side is 6 over 4. That also equals 1.5 when I divide to find the scale factor. And if you're in honors class, we have to show that the scale factors are the same to say that they have proportional sides. And they have proportional sides because of that same scale factor. Now that we found that they have the same scale factor and we found that the angle in between them is congruent, we can say triangle DOG is similar to triangle NAM because of side angle side similarity. Okay. All right, so if you need to review the flowcharts, go ahead and pause it. Otherwise, I'm going to move now on to our similar figures review. Similar figures review. Here we go. The quadrilaterals are similar, which means we can set up proportions to solve for our missing x, y, and z. You can see I already set up, or I already colored in the corresponding parts. And so I want to use those corresponding parts to make my ratios. I notice that my corresponding red parts, 28.8 and 9, that ratio is given to us. So I'm going to use that ratio in all of my proportions. So 28.8 over 9.9 equals, and we're going to do x first. So I went big over little trapezoid, so I'm going to do the same, x over 6. And I'm going to let you solve these proportions on your own. So go ahead and pause it if you want to solve it on your own. But here is the answer. X will be 17.45. Let's move on to the next one. Again, I'm going to use the ratio that is given, 28.8 over 9. And this time for y, again, big over little, that would make it 22 over y this time. Again, big trapezoid has 22, little trapezoid has y. All right, again, pause the video if you want to solve it on your own. Otherwise, the answer for this one is 7.56. And the last one, again, start with the ratio that's given, 28.8 over 9.9. And we're going to set that equal to our ratio for our corresponding purple sides. Again, 9 over z, big over little, since I did that for all my other ratios. And z will equal 6.53 when you solve that proportion. When we look at the scale factors, if we're going LMNO to PQRS, that's going from big to little. So it is shrinking or dilating it smaller. So we want to make sure that our scale factor will be less than 1. To do that, we're going to use our ratio that was given, 28.8 over 9.9. But I'm going to flip it this time, 9.9 over 28.8. Now I did little over big, because when I divide it, I'm going to get a scale factor less than 1, and that is 0.34. If we want to go the other direction from our PQRS, the small trapezoid, to the big trapezoid, we want to enlarge it or dilate it to get it bigger. And we are going to use 28.8 over 9.9 to get that scale factor. And again, because the bigger number's on top, when we divide it, we're going to get a number greater than 1. We actually get a scale factor of 2.91. So if you want to shrink a shape, you need to have a scale factor less than 1. If you want to enlarge a shape, you have to have a scale factor greater than 1. Moving on to the next question. And I've already marked the corresponding parts. How did I know I had corresponding parts? Well, PS is in the same position as HL. So I marked both of those in blue. And that meant the other corresponding parts must be matching up. All right. So we want to find the value of x. And I'm going to set up a proportion. On one side, I got, we're going to do 48 over 33. So big over little. And the same with my red ratio, 66.25 over x plus 18. All right, I'm going to put a parentheses around my x plus 18 because when I cross multiply it with 48, I want to make sure I multiply 48 by both terms. So that's going to be 48x plus 48 times 18, which is 864. And then on the other side, we got 66.25 times 33. And that is going to be, let's see, 2,186.25. All right, I'll let you finish solving this. So if you want to solve it on your own, go ahead and pause it. Otherwise, here are the answers. X will be 27.55 when you solve it. And then angle P and angle H in our similarity statement match up, which means they're congruent. So if angle P is 46 degrees, angle H, which is Y, is also 46 degrees. All right, so similar triangles, corresponding angles have to be congruent. Moving on to our next problem on our review. Here you can see I already took the overlapping triangles and redrew them. My small triangle in red and my big triangle in green. and then I labeled the parts that I had. We want to show these are similar first, so that means we got to make a flow chart proof. And when I look at this, I first notice they both have angle T. All right, so they both have angle T. I'm going to start there. Angle T is congruent to angle T, and that is an example of the reflexive property. All right, and then the next thing I gotta look for is another, I'm doing an angle flowchart because I'm missing the side TH. That's why I put an X there. So I can't do side angle side, I can't do side side side. All that I'm left with is doing an angle. I do notice they have parallel lines here. And so I'm going to put that in my flowchart first. So I'm given parallel lines. AH is parallel to MS. And I'm going to use the parallel lines to get some corresponding angles. So for example, this angle here slides down and matches with that angle. And let me put that into my flowchart. So the parallel lines lets me say that angle, I can't just call it angle H, I'm going to call it angle TAH, 3 letters. So I know which angle I'm talking about there. And that is congruent to angle M. I can just call that angle M because it's the only angle there. Again, that's an example of corresponding angles. And now that I have both angle bubbles filled in, I can now say that the triangles are similar because of angle similarity. Triangle TAH is similar to triangle TMS. So Zippy is wrong. It's not going to be side angle side because we are missing side TH here. We have to do angle similarity for our flowchart. So the next question is, how long is HS? I just want to point out HS only goes from here to here. So it's not 32. And in order to figure out, we have to figure out this portion here. That's the X on T to H. All right. And so we're going to set up a proportion. Again, 5 on the little triangle corresponds with 28 on the big triangle. And X corresponds with 32. And when you solve this proportion, you will get X is 5.7. Again, that's not my answer. HS, I need to take 32 minus TH, which is 5.7, and I get an answer of 26.3 millimeters. On the last part, angle TAH, that was my corresponding angle here in blue. That matches with angle TMS, the other corresponding angle. Because they're both corresponding angles, they're congruent. So that means the answer for this one is 54 degrees. Let's move on to our next problem. And here I've already made the flowchart for this one. Again, I did side angle side. And when you do this one, you want to make sure you have the corresponding parts that make the same scale factor. So when I do 18 over 3, I get 6. When I do 15 divided by 2.5, I also get the same scale factor, 6. So that gives me a clue on what sides correspond. We have vertical angles here in green. Remember, vertical angles, you need 3 letters. And O where the vertical angles are is the letter in the middle. And again, your side bubbles for honors class tell us that they do have proportional sides because they have the same scale factor. So we can say the triangles are similar using side angle side similarity. If you want to take a longer look at this flow chart, go ahead and pause the video. Otherwise, I'm going to move on to our last problem. Make a flowchart proof to show the triangles are similar. So just like every overlapping triangle problem, the first thing I'm going to do is redraw it into two separate triangles. And when I do that, it's pretty clear that of my three shortcuts, I don't have all the sides labeled, so I can't do side, side, side. Just looking at it initially, I don't have two pairs of sides, so I'm missing this side that corresponds with the 7 on the bottom here, so I can't do side, angle, side. So that leaves just one shortcut to try, angle, angle. And for angle, angle, I notice, again, both triangles have the letter A. That's an example of that reflexive property again, so I'm going to start with that bubble. Angle A is congruent to angle A. That's the reflexive property. All right. Now I'm looking for another pair of angles. And again, just like our previous problem, we have parallel lines. So I'm going to put that bubble in first. We got BC parallel to DE. And that is given to us. And the reason why we want that parallel lines bubble in there, it's going to show us corresponding angles again. So, for example, this time, this angle here can slide down and match with this angle. Those are corresponding angles. And let's go ahead and name them. We can't just call it angle C because there's more than one angle here at where C is. So we want to call this angle ACB. Notice the C is in the middle where the vertex is, and that is congruent. And we can call that just angle E because there's only one angle there. Again, those are corresponding angles. I have my two angle bubbles completed, which means I can now say they are similar. Triangle ABC is similar to triangle ADE because of angle, angle similarity. All right, that's our final review question. Go back and review parts of the video if you need to study more for the test tomorrow.